Ladies and gentlemen, welcome to a T-shirt Tuesday edition of Quarantine Science. We are in quarantine day like 4 weeks now. Today's topics are going to include balancing chemical equations. We're going to look at products, we're going to look at reactants, we're going to look at the law of conservation of mass, and we're going to dive into just exactly how we do the balancing of these chemical equations. Sit back, relax, and enjoy another awesome edition of Quarantine Science with Mr. Althouse. All right, let's go ahead and jump right into this. Now, when we look at balancing equations, the first one we want to look at is the reason why we do this. In a chemical reaction, atoms follow the law of conservation of matter. Atoms cannot be created, atoms cannot be destroyed. Okay, in a chemical reaction, they can only simply be rearranged. So the atoms that you have can't change. Okay, we're not going to create new atoms, we're not going to destroy atoms. The atoms that we have are the atoms that we have. When we balance an equation, all we do is make sure that our products is going to be equal to our reactants and that our reactants are going to be equal to our products. Now, what is a product and a reactant, you say? Great question. Let's go ahead and jump right into that. So what you see right here is a simple, easy chemical reaction, okay? We have H2 and O2 that react to form H2O, okay? So this is a pretty simplistic one. When we look at this, we always want to look at the left-hand side first. We looked at the left-hand side first, okay? These are going to be known as our reactants. They are what are reacting together, okay? So these are our reactants. So that's what's going to do the reaction, okay? So think of it this way. They react to produce what we have over here on this side. These are going to be our products, okay? So in this example, H2 is a reactant, O2 is a reactant. These two, this plus sign, shows you that they're going to be reacting together, okay, to form our product, which is going to be H2O in this case. It's going to be just simple water. So our products are on one side, our reactants are going to be on the other. In the end, we got to look at this and make sure that we can balance this out. We need to make sure that we have the same number of hydrogens on one side as we do on the other side, the same number of oxygens on this side as we do on this side. And as we go ahead and dive into that and start doing that, I'm going to go ahead and erase this here, okay? And we're going to do this pretty simply. What I want to do first is just go ahead and draw a line. I always like to draw a line to separate my products from my reactants. When I do this, it makes it a little bit easier for myself, makes me see it a little bit better. And then what I want to do is I want to put the first, whatever one that I see. So I have hydrogen here, so I'm going to put an H here, okay? So I have H. The other one that I have is oxygen, so I'm going to put my oxygen down below. We're going to do the same thing to the other side. I have H and I have O. I always find it easiest to do hydrogen and then oxygen. I always do oxygen last. It's a little trick. When you go through, do everything other than hydrogen and oxygen first, and then do hydrogen and then do oxygen at the very, very end. Now, when I do this, I want to count up the number of atoms that I have. So I look at this side right here, H2. That tells me I have 2 hydrogen atoms. So I simply put a 2 right here in front of it, okay? Then I continue to look at it. I have O2, pretty simplistic, okay? I have 2 oxygen atoms. All I'm doing is looking at it and saying, all right, I have 1, 2 oxygens, I place it down here. Because the number that I have over here needs to be equal to the number that I have on this side. Now, when I look at this side, how many hydrogens do I have? Well, I look at it, I have H2O. So I have 2, okay, that subscript 2 there tells me I have 2 hydrogen atoms. Go ahead and put my 2 there. How many oxygen atoms do I have in this case? Well, I only have 1. Okay, there's no subscript over here. So I only have 1. So when I look at this and I go through and I ask myself, is this a balanced chemical equation? Do my reactants equal my products? Well, the answer to that is obviously no. Okay, I have 2 hydrogens, 2 hydrogens. Is that good? That's good. The problem is this. I have 2 oxygens in my product or in my reactants. I only have 1 oxygen in my products. We're going to need to balance this equation out. Here's the biggest thing that you need to understand with balancing chemical equations. You can only add coefficients in front. I cannot go up here and just go, well, I'm just going to make that a 2. Okay, I can't add a subscript there. I can't just make that a 2. That is not allowed. That is not okay. All right, you just changed this from water into something completely different. This is no longer water. Okay, so I go ahead and erase that. And I have to add a coefficient in front. Now, when I add a coefficient in front, okay, I'm putting it in front of the entire thing. So if I have 2 oxygens over here, I need to get 2 oxygens over here. So I'm going to put a 2 in front of this H2O. And what that's saying is that I now have 2 H2Os. So I'm going to go through and adjust everything on here. Okay, I'm going to go ahead and scratch that 1 out. I don't need that anymore because there's not 1. And now I have oxygen, 1, 2. There's a 2 in front. So I have it's like I have H2O, H2O. Okay, it's like I have H2O, H2O. So I have 2 oxygens. So I'm going to put my 2 down here now. Do these line up? Yep, you're good to go. But wait, since I put the 2 here, how many hydrogens do I have now? This is where I really got to go back and look at this. How many hydrogens do I have? Well, I have H2, but now I have 2 H2s. So instead of having 2 hydrogens, I now have 4 hydrogens. Back and look. Are we balanced? Does this equal this? No. I have 2 hydrogens over here. I have 4 hydrogens over here. Okay? So I can't just, I'm going to erase that and turn this into a 4. Nope, not allowed. Can't do it. You can't change the subscripts. Okay? What you have is what you have. Instead, what I can do is I can add a coefficient in front. Okay? So I look at my H2, and I'm just going to put a 2 coefficient in front right there. I know it's kind of hard to see. Okay, so I put my 2 coefficient in front. By putting my 2 coefficient in front, it now says that I have 2 H2 atoms. So when I go through and look at that, I can go ahead, do my oxygen. Oxygens don't change, leave them. Nothing changes there, but now I have 2 H2s. So instead of having 2 hydrogen atoms, I now have 1, 2, 3, 4. I have 4 hydrogen atoms. And now I look at it, and now am I balanced? Well, I have 4 hydrogens in my reactants. I have 4 hydrogens in my products. I have 2 oxygens in my reactants. I have 2 oxygens in my products. So there you go. That's how you balance an equation very simply. You add coefficients in front, okay, to make all of these atoms balance out. One of the questions that I always get from my classes is, Mr. Aldhouse, can I just make this like a 0.5? Can I add a half? It's got to be whole number coefficients, okay? It's got to be whole number coefficients. I see a lot of times people will want to do this. They'll want to put like a 1 in front. You can do that. If that helps you understand that there's only one of them, you can do that. In the real world, you're not going to put that. You're not going to need it. As you continue to go through chemistry and develop as a chemist, you're not going to need that 1 in front. You're going to know that that's simply O2. Okay? So that's balancing chemical equations. That's a good start. Remember, a couple things that you need to understand. On this side over here, we have our reactants. These elements are reacting to produce what we have on our product side. As we go through and do this, all of these elements, okay, all of these atoms have to be balanced. I have to have the same number of products as I do reactants, okay? My reactants on this side have to equal my products on this side. It's a must, okay? Again, a little trick that you can do, as I always like to balance the chemical equations, I'll do everything first, and I'll leave hydrogen and I'll leave oxygen at the very, very end. Okay, you'll notice that hydrogen and oxygen are going to be the ones that kind of screw everything up the most. So go through and get everything in as much as you can. Then at the very end, go through and take a look and balance your hydrogen and then balance your oxygen. And you may have to go through and make adjustments to the other ones, and that's going to be totally normal, okay? As you balance chemical equations, there's a little bit of trial and error to it. You're going to make a change to the product side, and then you're going to have to make a change to the reactant side. And then you may have to go back and make another change to the product side to equal out back over to the reactant side, okay? But in the end, according to the law of conservation of matter, they have to be the same. The number of hydrogens that I have on one side has got to be equivalent to the number of hydrogens that I have on the other side, and vice versa. We'll dive a lot more into this later. I just wanted to give you a quick, simplistic explanation of the different parts of balancing an equation, the product and the reactants, the why we balance the chemical equations, that law of conservation of matter, and then last but not least, a simple step-by-step guide on how to balance those chemical equations. I'm telling you, you're going to learn to love this. It's one of my favorite things to do. It's absolutely one of my favorite things to do in chemistry. So you're going to love this as we work through it. The questions will get a lot more difficult and a lot more difficult. This right here, this is basic. Okay, this is simplistic work. All right, we're going to enhance on this big time. There'll be more videos in the future to help you with that. But that brings us to another end to a wonderful edition of Quarantine Science with Mr. Aldhouse. It is a beautiful day outside. Go and enjoy that weather. It is gorgeous. And stay safe, stay healthy, okay? Continue to put in the hard work. My students, you guys are doing fantastic. Continue to put in that hard work, and thank you for everything that you're doing. All right? Stay safe, guys. Have a great day. Oh, and remember to live the Irish way.